Okay, here we go. 2015 PAT. Gonna be going sort of quick through it, as quick as I can anyway. And again, just pause, rewind as needed. All right, question number one. Another representation of the expression 2/3 to the 4 is, well, power. One of our power rules allows us to uh, bring the exponent to the top and to the bottom. So that's the same as having 2 to the power of 4 over 3 to the power of 4. And expanded 2 to the power of 4 just means 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. So that's not it. That's not it. That's adding. Bingo. Answer is D. Okay, easy one. Let's move on. Uh, okay, question two. I feel like we did this in class. We've done a lot of these, but here we go. We'll just do it quickly. So match each of the following rational numbers to its corresponding point on the number line. So we're going to notice a couple things here. So look at our number line first, from 0 to 1. Let's count how many divisions we've got. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's good to know that each one of these spaces is 1/8. Okay, that'll help us locate our answers on the number line. All right, so we've got -1 3/4 is located at, right, so here's -1, and we've got some points that are approximately 3/4 down, but we have to make sure. Now, they didn't show us exactly which ones are our quarters, but 2/8 is the same as 1/4, right? It's just an equivalent fraction. So for every 2/8, I could figure out where my quarters are. I could go, there's 1/4, 2/4, 3/4. Okay, so we are at point number 1. That's going to be our first point. Okay, point number 1. 13 over 8 is located at which point? So that one is going to be helpful to convert that to a mixed fraction. 8 goes into 13 one time, and that leaves us with 5/8 left, so 1 5/8. So here we are at 1. We're going to have to go 5/8. And each of these little spaces is an eighth, so that's going to be easy to count. So here we have 1/8, 2, 3, 4, 5/8. Okay, count carefully because you could end up there at 6/8, which is the same as 1 3/4. Okay, so there we go. Point number 7. That's our second one. 1.125 is located at which point? So we have a decimal on this one. We're going to want to see what is that as a fraction, 1.125. Now what's the easiest way? Here's one way we could do this is we know all the points up above are on one of these lines, okay? And each of these little lines, let me make sure I'm talking about this. Each of these little marks here are an eighth, as we said. So we could, there's a couple things. So 1.125, that's just a little bit more than 1. Let's look at 1. We only have one dot here on the line that's just a little bit more than 1. So I'm already pretty confident that that's my answer. We already know that this is 1 and 5/8. Do we say 5/8? Yeah, 1 and 5/8, which is going to be a lot more than 1.125. You could calculate that as a decimal if you just want to see what it is. 5/8 is 0.625. So this would be like 1.625. So 1.125, this has to be it here. We also know that that's 1/8, right? Past 1. So that mark there is 1 and 1/8. And if you divide 1/8 in your calculator, you're going to find out that 1/8 is indeed 0.125. So that would give us 1 and 1/8. Okay, so our next point is number 6. -0.875. So that's a number between 0 and -1. Here's 0, here's -1. They only gave us one option. Again, that's got to be it. If you want, you could check 1, 2, 3, 4, 5, 6, 7. 7/8 would give you 0.875 if you put it in your calculator. But in any case, it's really the only choice. So that last number is 4. And there's our answer, 1764. next. Why am I only on? Oh, okay. All right. Aaron buys a cheeseburger for 6.50 and a container of milk for 80 cents. Sam buys a tossed salad and a bowl of soup. The soup costs $2 more than the salad. Sam's meal is less expensive than Aaron's meal. Okay, so reading that might feel like an overload of information. Read it once, read it a second time now, and just write down what we know. It helps to identify so we can keep everything straight. So pay attention to the names, for example. First we have Aaron. Okay. He bought a cheeseburger for 6.50 and he bought a container of milk for 80 cents. Okay. So we know the cost of his meal. And then Sam, he buys a salad and a bowl of soup. Okay, salad and soup. Now, they didn't really tell us the cost. They told us that the soup costs $2 more than the salad. So I don't know what the salad costs, and they don't give us any more information about the salad. So why don't we just call this here S? S for salad, or the cost of his salad. Um, the cost of his meal is going to be the cost of the salad, S, plus the cost of the soup. And they said the soup was $2 more than the salad. So we could represent that as soup, right? Plus $2, right? It's $2 more than the cost of the salad. Um, they told us anything else? So they said which of the following number lines could represent the price of Sam's salad. Now, did they tell us anything else? We know Aaron's, we know the soup. 6.50 and that. Hmm. Okay. Oh, yes. Here's the part of the last information we need. They say Sam's meal is less expensive than Aaron's meal. Okay, so that helps us to decide what to do with this information we wrote down. And you can see from our answers we're talking about an inequality. So that less expensive or less than is going to be important. So we said Sam's meal is less expensive than Aaron's meal. Okay, so Sam's meal is whatever his salad costs plus the salad plus two. Actually, you know what? Let's just figure that out first on the left. This is the same as S, and we don't need these brackets here. It's just for addition. We're not going to change our signs or anything. It's going to be S plus 2. Get rid of those brackets. So S plus S is 2S, and then plus 2. So that's a way of representing the cost of Sam's salad. We don't know what it is, but we just know that it's the cost of the salad, and then the cost of the salad again plus $2. So that gives us 2S plus 2. So Sam's meal we can represent like this, 2S plus 2. Whatever that cost is less than Aaron's meal, which we didn't calculate that. Let's do that now. That's $7.30. So now we have an inequality that we can solve. That we know how to do very well. So we're going to subtract 2 from both sides. And hopefully we got some more room there. Yes, we do. Okay, so that's going to leave me with 2S. Be gone. And this will give us $5.30. Now to get S alone, we're going to divide by 2. And we're left with S is less than, let's see, that's 250 and 15 should be 265. Okay. So S is less than 265. That's saying we don't know the cost of the salad, but we know that his salad needs to be less than 265. Okay, because his meal is less than Aaron's meal, and if his salad were more than 265, the cost of his meal would be more than Aaron's. So we want, so let's find that one here as less than 265, not including 265. That is going to be okay. All right, next, use the following information to answer question 3. So we've done this one before. We take the square root of p plus q over 2. So p plus q is, I'll just read the question again. This is the letters p and q in the expression, the square root of p plus q over 2, represent consecutive perfect square numbers. So consecutive perfect square numbers would be like 3 squared becomes 9. So that's 9 is the perfect square. The next one is 4 squared, which would be 16. Next one is 5 squared, 25. These are consecutive numbers. So these two are consecutive. These two are consecutive. They're one after the other. Okay. So which of the following number lines best represents the value of those two numbers over the square root of 2? So if we have two numbers and we divide by 2, it's like taking an average, right? If I had 10 and 20 and I added them and I divided by 2, I would get 30 over 2, which is 15. And between 10 and 20, 15 is right in the middle. So that average is going to be in the middle. So if I have a perfect square and I add the two numbers together and divide by 2, it's going to give us a value somewhere in the middle of those perfect squares. So my square root for that, the square root of that expression here is also going to be in the middle of p and q. Okay, so my answer there is C. That's a shorter explanation than I did before, but we have seen this one before, so let me keep moving on. This one we've done before, and you guys are pretty good at these. I'm going to skip this for now. Feel like we've done this one already a number of times. Okay. All right, we've done this a couple of times, but this is a good problem, so we'll do it one more time. So it says, the arch in the diagram below forms a complete half circle. Okay, that's a half circle there. The black support beam in the diagram is 3 meters and 3.6 meters in length. Okay, so this here is 3.6 meters in length, and it's 3 meters above the surface of the water. So from here to here is 3 meters, 3.0 above the water. Note the diagram has not been shown to scale. To the nearest tenth of a meter, the diameter of the arch is. So we want the diameter of the arch. Okay, so since this is a semicircle, this is my diameter from here to here. Okay, so I want my diameter. Remember, if we have radius, we can get diameter. So I can figure this out, then I'll know this, or vice versa. Though that's going to be helpful in these type of problems. Now, a lot of these problems, here's your first giveaway. We've got a line going from 2 points on this circle. That's a chord. And we often use with one of the rules we learned about a chord is that if we have a line from the center of a circle and it meets, and it meets our chord perpendicular angle, so 90 degrees, we know that it is dividing this line into two. It's bisecting it. So since this one was 3.6 meters in total, we know that half of this is 1.8. 3.6 divided by 2 would give us 1.8. Okay, so I know this length, and they said that this is 3 meters above the water. So I've got a line here meeting at a right angle here. Great. Seems like I can draw a triangle. So if I go from my center of my circle to a point on the circle, that's my radius. So guess what? I can solve my radius now using Pythagoras. So I'm going to have, that's my long side, so I'm going to make that r squared. It's the long side, it's opposite to my 90-degree angle. So r squared is equal to 3.0 squared. We don't need the 0.03 squared plus 1.8 squared. R squared is equal to 9 plus, I believe this comes out to 3.24. Done this problem a few times, but let's just make sure. Oops. Okay. So we have 9 plus 3.24, which is 12.324 is equal to r squared. So to get r now, we take the square root of both sides. Square root of r squared is r. Square root of 12.32. What am I saying? Square root of 12.24 is 3.498. And we could round that to 3.5. So, oh, I got 3.5. Maybe I'm going to get excited and go, that's my answer and be done. But let's not stop thinking about the problem. Make sure it asks us for the diameter. So we have the radius. The radius is, the diameter is twice the radius, right? So diameter is equal to 2 times the radius, 2 times 3.5, which is, of course, 7. So there's our answer. Our diameter of my circle is 7.0 meters. All right. Okay, let's go. Yeah, we've done these questions before. Um, Okay, we've done these before. You guys are doing good at those. We've done this a number of times, but I've been asked it more than once as well, so let's do this one. Okay, the letter W is at the center of the diagram below. And represents the location of a wireless router for internet access in a square house. Here's our square house. Okay. The router provides access to the area represented by the dotted circle, so that Wi-Fi can reach out to here, it can reach throughout the whole house and even a little bit outside of the house. So if you sneak up, hang out by the back door, you can use this Wi-Fi. All right, so the router provides access to the area. Yeah, I already mentioned that. This circular area has a diameter of 20 meters. Okay, so diameter 20 meters. And a lot of these problems, we're going to always be using the radius, right? Because our radius, we're making triangles a lot of times. Well, pretty much all the time with these problems. So we know that radius is going to be helpful. Now they ask us, they say to the nearest tenth of a meter, the distance x from the router W to the middle of one of the outside walls is. So here's our distance x they're talking about. Here's where our router is located. So they're saying the distance from here to here. What is that? And they're calling it x. Okay. So let's use what we have. We've got this square and I'm in the middle of it. So it means I'm halfway from here. The distance of this square is from, we're in the middle. This x is halfway here. And so being in the center, we're halfway between the circle this way. Let me just do this again. I'm in the center of my square. I'm halfway here and I'm halfway here. Okay. So what I want to show you is that this square, we can think of dividing it into 4 equal parts. So if this is x here, this is also going to be x, right? Because if I take a square, I'm in the middle, it means I divide it this way and this way. We now have 4 smaller squares. So these are squares. So if I'm calling this x, that means this is also x, right? Whatever this distance is, it's going to be the same as that distance, okay? So we're looking at these two sides. This is x and this is x. Well, we can complete our triangle now with our radius, right? From the center right to a point on my circle. That's going to be my radius. Okay, so now usually to solve these problems, we need at least two numbers, right? And then we can solve the other one. But we have um, we have an unknown, but it's the same unknown. So let's see what that looks like, okay? So let's try and solve this here. We're going to try to solve for x. We've got, oh, and we know r, by the way. R is not unknown, right? R is, we said our diameter was 20. So that means our radius is 10, okay? 10 meters. All right. So again, r is my longer side, so we write that as our c squared equals a squared. A squared plus b squared equals c squared. So we could say this is like my a and this is my b. So a squared plus b squared, because it's the same value, is equal to c squared. Now, from polynomials, we know we can add like terms together. We have an x squared term and an x squared term. How many? Like 1 x squared. So we can add those together. That's 2x squared is equal to, oh, and I don't need to be putting the r because we have the value for it, right? We know r is 10, so 10 squared. 10 squared, by the way, is 100. All right, keep working down here. And that's not a fraction. I was just highlighting that. Okay, so we can now solve this, divide both sides by 2. But x squared is equal to 50. Now I have something very familiar. I'm going to take the square root of both sides. Square root x is x. I'm going to take the square root of 50. 50, take the square root. 7.07. 7.07. And it said to the nearest tenth of a meter, the distance x is. We're going to round that up then. Round that up to 0.1. So here we have it, 7.1. That's the distance from the router to the wall. Okay. To the middle of the outside wall. Okay, there we go. We've done this question before, and here it is. That's answer is carpet 2. So you check your answer if you're just breezing through this. I won't explain that one again. There's just no time this evening. We've done that one before. We've done this one before, scale factor question. And we found out that these two were the same because we get the same scale factor here. So for example, if I divide this by this, I get 1.5, and I divide this guy by this guy, I also get 1.5. So the scale factors both match. So it was turbine 2 and 3. We've done these before. If you try this with other ones, you're going to find that this part of the scale factor won't be the same as this. So it's not proportional. Okay, all the parts have to have the same scale factor for it to be proportional. Okay, we've done this question a few times, but I'll do this once more just because in theory it's an easy question, but it takes some thinking. So they told us the volume of each cube is 8 centimeters. So here I have a cube. The volume is 8 centimeters cubed. So with a cube, we know it's a square, right? It has the same dimensions. Let's call this dimension. If this is an x, then this is x, the height and the width, right? The width, the length, and the height. But really it's not width, length, and height because they're all the same. There's not one that's wider or longer. It's just they're all the same side. So the volume of a rectangular prism would be length times width, right? The rectangle, and then the height, how high it is. But since everything here is the same, we can just call this x times x times x, x cubed, right? So we're just saying that the volume of a square is some number times itself 3 times, right? So can you think of some number let's just get rid of these centimeters cubed for now. I should have said cubed. Some number to the power of 3 equals 8. Let's think about it that way. If I say something to the power of 3 is equal to 8, what is that something? It's 2, right? 2 cubed. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So we know that the dimensions of this cube here are 2. 2 wide and 2 high. 2 by 2 by 2. Okay, that was volume. Now it's asking us for the total surface area. So we're talking about area now. So total surface area of the 3D object. It's going to be important to know the surface area of one of these squares. These squares have all the same dimensions. They're all 2 by 2 by 2, right? 2 by 2 by 2. So the area of one of these squares is going to be, we know the side lengths now are 2, so 2 times 2, right? 2 times 2 is 4, so 4 centimeters squared. This before was centimeters cubed for the volume. Okay, so 4 centimeters squared. So that means each face is, that's 4 centimeters squared. That's 4 centimeters squared. 4, 4, 4, 4, 4, 4, 4, etc. So we're going to add up all those faces. So remember, we can think of this in kind of like 3 parts. We've got top and bottom are always going to be the same. We've got left and right, and we have like front and back. Okay, so let's look at the top. How many of these squares I have? I've got 1, 2, 3, 4, 5. If we think of what this looks like on the bottom, it's exactly the same as on the top. So here I've got 5 times 2. I have 10 of these faces on the top, and then again on the bottom, right? There's 10. Okay, so let's look at the front side. If I look at the front, I can picture this face, 1, 2, 3. And then if we're looking from this direction, I'm going to have this exact same thing. Imagine, you can see this is symmetrical. So we're going to have a scan here, like 1 here, 1 there, and 1, we can't see it, but it's there, right? 1, 2, 3. So there's, right, 3 in the front, 3 in the back, 3 times 2, the total is 6. Okay. And then think of the left and right side. So we'll call this the right side. Here's 1 face, 2. And this one, we can see a part of it, 3. Again, if we look from this side, we're going to have the same thing, 1. Can't see it, but it's there, 2, and 3. So there was 3 on the right. We'll multiply by 2. We get 6 of those. So just let me get rid of this so there's less clutter. Okay, so this is the number of faces on this cube. 10 plus 6 plus 6 is 22 faces on the cube, 22 squares. And then we're just going to multiply that by the area of each one of those squares, which is 4 centimeters squared. So we take 22 times 4 centimeters squared, which is going to give us 88 centimeters squared. And there it is. Okay, so also you can ask for manipulatives on this exam, so I can give you cubes also if you want to look at those. But here we go. Okay, solving of equations. You guys are pretty good at those. I'm going to skip this one just for time, sake of time. We did this in one of our classes the other day as well. So might be worth doing. I'll do this one quickly. So 4 students simplified the expression. Their answers are shown below. Who simplified it correctly? Okay. Couple ways we could do this one. I'll just do it the most straightforward way and the way that we're probably used to seeing from this year. I'm just going to expand this on the top and on the bottom. I'm going to multiply this in here. So 3x times 4x. So remember, when we multiply our numbers to numbers and our variables to variables. So I'm going to have 3x times 4x first. So 3 times 4 is 12, and x times x is x squared. Okay. And next I'm going to multiply 3x times negative 6. So 3 times negative 6 is negative 18. And then x times, well, there's nothing else there, so it's just going to be x, right? X times. There's no other x's to multiply, so we just get x. Okay. And then that's all going to be divided by 2 times 3x. There's no x here, so we're just multiplying the numbers. 2 times 3, we get 6x. All right. I'm running out of space here, so I'm going to go up this way. So now I'm going to rewrite that. 12. So when we divide this, remember this whole line here means we're dividing 6x into this whole thing, which means I have to divide this into each part. If I only divide it into one of these two terms, I haven't divided the whole thing by 6x. Okay, so I've got to divide that into both parts. So we have 12x squared over 6x minus 18x over 6x. Now I can simplify it. So let's do this part here first. 12 divided by 6 is 2. And x squared divided by x, we can cancel one of those terms of x, right? X squared divided by x. That's like saying x to x over x to the power of 2 over x to the power of 1. We subtract our powers. We're left with x to the power of 1, which is just the same as x. The other way we could think of doing that is if I have x squared over x, that's the same as x times x, sorry, equal to x times x over x, and I can cancel one of those factors of x, and then I'll be left, sorry, it's a bit messy, I'll be left with 1x. Either way, x squared divided by x leaves us with x minus 18 divided by 6 is 3, and x divided by x is 1, so that's just going to cancel out. So we've got 2x minus 3. So who had the right answer? Student number 2. Answer is B. Okay, this we've done a number of times in class, and there's couple of different ways to do it. There's a quick way, and then there's the easy way. Probably the easier way. Easier way is plugging in the numbers and seeing which one is right. The quick way is looking at the signs, realizing that we're evaluating our multiplication division first. And if the question says we want this to result in the lowest value, means we want this to be the most negative. So we would plug in negative. We would want a negative number here for P. So that would be, because it's odd exponent, we'd get a negative times 2, which is a positive, would result in a negative value. Now here, if I'm subtracting, let's imagine that Q is a negative value. 6 divided by some negative value would give us a negative, but since I'm subtracting here, if I subtract a negative, that's like adding a positive, and that would make our number larger. We don't want our number to be larger. We want the lowest possible value. So if I pick a number that would make this 6 divided by Q positive, when I subtract it, it's actually going to be a negative number, right? So long story short, I need a negative for P and a positive for Q. So this is my answer here. That's like, for me, the quick way to do it. The other way would be to just plug these in, right? 2 times, P cubed minus 6 divided by, and you could test the first one, right? 6 divided by negative 2. And you'd end up getting 2 times negative 8, which would give you negative 16. And here you'd get 6 divided by negative 2, which is negative 3. But when you subtract a negative, you add a positive, and you get negative 13. That would be one of your values, and then you would test all of these and see which one gives you the most negative value, and it ends up being C. Okay, but I'm not going to go through plugging in all those values to test them. That takes time. So but that you can do it that way, or you can just kind of reason through it by looking at the signs. Okay, this question we've done before. It's really not a bad question. It's pretty easy, but it's saying you just got to read carefully, okay? That's the most important thing. It says each gray square, okay, these ones here, has an area of 77.4 centimeters squared. Centimeters squared, the area. Okay, be careful. And each black square has an area of 4.84. So 4.84. Then it says to the nearest tenth of a centimeter, what is the height of the design shown above? So they're talking about the height here. What is this from here down to here? So this is talking about a distance, like a side length. We need to get the side length of these squares so that we can add these up. So if I have a square, my side length I get by taking the square root of that number, right? So I'm going to take the square root of 77.44, and that's equal to 8.8. Okay, so each one of these sides of this square is 8.8, 8.8, right? And same with the one over here, the little black square. If we take the square root of 4.84, we get 2.2. Okay, so that's the side length of this 2.2. Now, here's a part where we just have to like understand what they're asking us. They're not asking for us to tell them the perimeter. They're not asking for us to add up this piece, then that piece, then that piece, and all this stuff, right? They want the distance here. So from, yeah, from bottom to top, or top to bottom, from here to here. So they made this interesting, complicated looking shape, but we just want to see this here. Look at my square if I draw this over here. I know my square we said is how high, what the length is, 8.8, right? So here I've got 8.8. And then from this big square, from this bottom of the square to the top of the square is another 8.8. And then from the bottom of this square to the top of this square is 8.8. So we don't even need to know this distance, at least not yet. But to get the final distance, we do need to know from the bottom of this little square to the top of this little square, and that's 2.2. So now we can add all of these up. So we've got 2.2 and 3 times 8.8, or you could just add them one at a time, but I'm going to multiply because that's quicker. That's why we have multiplication. 8.8 times 3, 26.4, plus 2.2, 28.6, and there's our answer. 28.6. Okay, pretty easy question, but you have to do a little bit of thinking for sure. Again, we've been through these questions. It's asking us to mirror. It says to with a 2D shape. Hang on. An incomplete 2D shape and its line of symmetry are shown in the diagram below. So line of symmetry is where the image would be mirrored onto the other side. So if I were to finish drawing this in, I would do the opposite of what I see here, go in that direction, and then I can see I'm going over 3 this way and 1 that way to get my diagonal line that I have there. So it's got to maybe helps to turn your head a little bit, right, and sort of see what that looks like. But we're going from, should be going from here to here, and then we're going down 2 and over 3. So we're going to be down over 3. So going from here to there, and then I'm coming back here. So this is a tricky one to draw, to be honest, but Now it asks us, once you've drawn that, uh, when the 2D shape is completely drawn, how many points will be inside? Well, we can just count them up now. 1, 2, 3. Okay, so answer is 3. Do that one. We've been through these. We went through this one. We've been through a lot of these questions. Um, hmm. This is a good one. Kind of a few different angles going on, and we have to pay attention. Think of our rules. We don't have that many to think about. We've got central angles, inscribed angles. We talked about isosceles triangles. Um, and that's going to come up in this question here. So we're trying to find out the value of this angle here. Now, the thing that tricks a lot of people, and they've put an answer there to throw you off, is we're looking at, oh, here's an angle that goes to the center of my circle. And then here's an angle that goes, to a point on the circle. And we're thinking, oh, yeah, so we know that this is twice this angle. So this one's got to be half of that one. And if we do that, you divide by 2 and you would get 47 degrees and think, oh yeah, there's my answer and I'm done. But that's a trick. No, it's not the answer. So in order for that rule to be true, that has to come from the same point. The same 2 points that angle has to start at. So the central angle, this would also be a central angle here, right? If we drew an angle from here right to here. And from those same 2 points, we have the inscribed angle. Now we can say that this is 2 times that. That is true. Okay, so, but guess what? We're in luck. If we can find this angle, we add that to this angle, then we have that central angle from here to this point. Okay, so our first job is to find out that angle, this missing angle here. Now, sometimes it's obvious you can see to see an isosceles triangle. For some reason, even when I did this problem the first time, I was kind of stuck on what to do. And for me, it was partly because this angle is so huge and it doesn't really leave me much space to kind of think about this being, an opposite angle, or I don't know if that's the right term, but an angle uh, that stands out to me. But what is important to notice is that this is a radius, and that's a radius. They both come from the center, so we know they're the same lengths. Anytime we have a triangle with 2 same lengths, we know we have an isosceles triangle. And we also know that the 2 angles that come from those 2 lengths are also going to be the same angle. So that's all to say that this angle here is the same as this angle here. So that one's 75, and so is that one. So since we know both of those angles, we know that this is 75 and this is also 75. We can use sum of angles to get this one. So 180 degrees minus 75 plus 75, 180 minus 150, 30 degrees. Okay, so there we have it, 30 degrees. So now we know this angle is 94 plus 30, which is 124 degrees. Okay, so we know our central angle now is 124. So now we can get this one because it's going to be half. So half of that, 124, it's going to give us 62 degrees. And that is our angle here. And there it is. Boom. All right, I'm going to stop this recording. It's a bit long and it's getting late. This might be the last one. So we've gone over as many PAT questions as we can. Um, been practicing for a while, so hopefully I'm just going to wish you guys good luck, and we'll see you tomorrow.